Okay, so let's get started. I think uh, first of all, let me share my screen. Okay, share my screen. Can you see my screen?
Yeah.
Okay, thank you. So what we will do today is we will just focus on three things. First of all, it's all about time series data analysis using Python. First, we will understand what is time series data, and also we will be doing it's more practical. We will be doing some data cleaning and preparation via Python, and also some time series visualization through Python. These are the things that we will cover today. So what are time series data? It's like any data that has been recorded over time or in a specific time interval that's called time series data. Example could be temperature, rainfall. So all the environmental data that has been recorded over time, that's called time series data. Okay. So since it's more practical, I'm gonna show you can you see my screen now, maybe?
Yes.
Yep, yep. You can type as Google Colab, okay?
Yeah.
And then enter.
Yeah.
Yep. And then you open the first web browser, okay? You already logged in your Gmail account, or okay, cool. Then you will be presented with the same screen as I have been.
Yeah.
Okay. Then you can create a new book. You click new book and it takes a bit of time. Then you can give a name for your projects. Okay. On the title, click once and you can say like time series data analysis. Okay. Then enter. Done.
Yeah.
So, and the next, can you hear me? I don't know if you can hear me online because I'm recording this one. So can you check? Let's make sure that we are recording.
Yeah.
We do. Uh-huh. Okay, thank you. So now you have created the name for your project. Then we try to upload our data. So Uh, can you also open the weather data, whether this data maybe you have already used or not? So weather nation, net.australia.
Yeah.
Okay, cool. Now you have just open this file on this page, weather station. You can download like weather data. It's for free. Okay. Here you can see the weather station name. Can you see that?
Yeah.
Okay, cool. So then you can go down and click our Appplot USQ. Appplot, there is a, okay, there should be a USQ Appplot. Yep. You click that one. Next one, you want like daily data, hourly data, 10 months data, or income intensity. So we will go for the daily summary. Okay. Then from which date to which date do you want to have this data? So let me just remove this data. Okay, no need to. So, for example, you're gonna go and consider the last 3 months. For example, we will consider from 1st of April, okay? And date from 1st of April until, for example, today, okay?
non-Shine.
Okay. So, mm, we put it here. So we put it, and then put it here. Okay. Now you can click here the business already selected. You can select from first topic until today, for instance.
Yeah.
Yep. And then download. You can click on the bottom of download. So now you see your CSV file has been downloaded. Okay. Done.
Yeah.
So you can open that data, that CSV file. Can you open it? So there you can have a quick look at the inside of this Excel sheet, what we have inside. At the end, there is also text data. You can remove that one. Okay.
Yeah.
The end column, there is end of data, so you can remove that and save. Done?
Yeah.
Yep, cool. Next thing, we will go back to our Python page. Here you can click on a file. Can you see my screen? Here is a file folder. You click there. Sometimes it does not pop up, so you have to click for a while. There should be yeah, now. Okay. Now there is can you see what I see in my screen? That you can, here is an upload option. You can hit that button. Yep. And then select that CSV file. Okay.
Yeah.
Done. And then hit OK. So it gives you a warning. You have to save it. So we don't make that one. So now it has already successfully been uploaded and it has been listed under these sections.
Yep.
So it has been listed here. What you're going to do is, first of all, whatever you're going to do in Python, maybe you already have experience. First, you have to import the library that you need. Okay. So we go one by one, like import the pandas as PV. And then we're gonna have our data frame like pandas read our underscore CSV file. Inside parentheses, you add the quotation mark. Inside double quotation mark, you add your CSV name file. Okay. So you can exactly with the same spelling, with the same space, it should be added. Otherwise, Python is case sensitive. It will not, you will face any error option.
Yeah.
So, and then since it's a CSV file, you add a CSV. So, done?
Yeah.
Okay. Then you hit the run. Run button is, if you see my screen, if you can see my screen, hit that button, it will just run the Excel file. Yep. If you didn't face any problem, for example, any error message pops up, it means we are good to go. Then you can, if you want to just see what is inside the Excel file, you can just write df.hit and then press the run again. So you can see what is exactly that inside of that CSV file. Can you see that?
No, I think, do I need to install the pandas library?
Yep. First of all, you have to do that. Sorry. With Sundays.
Oh, let's do that.
Now, put the line button. Nice, cool. Yeah. Now you can, if you want to see inside the CSV file, you can just write data frame.h and parentheses also you can add it.
Yep.
Done? Okay, cool. So you can look at the Excel sheet. It only gives you 5 rows. You can see there are some text data inside, for example, weather station and at USQ Tombo at lot. That's the, for example, text data that is already inside this CSV file. Okay. Then you have your data and it looks a little bit messy. We need to just clean it up. So how are we gonna do that, or should we at least can be just see it in a more nice way? Is you add another code column and you hit the code, so you can import the same write the same code as import handles as PD. Then the if equals to you handles with the CSV file underscore CSV and aside parentheses and also the quotation mark you add the name of your CSV file. So and then after this you add a comma and you hit enter, you write like some. Okay.
Yeah.
So then you're gonna like write as a, because Python is like based on C parser. It's very sensitive, very strict. If there is a messy data, so for example, it does show you, but if you want to, since in this data, you can see there is 2 columns or 3 columns are extra. So text data, we don't need the text to be displayed. We want only the quantitative data. So what you're gonna do is just write another function, engine, write engine equals, and inside the quotation mark, you write Python. So again, add a semicolon, a comma, sorry, and then hit enter, you write as a, okay, so Python, and then you write, for example, how many rows you're gonna escape, okay? Each one of them are considered as a row. If you look at your data, for example, here, what are the rows that we do need? For example, the weather station, we don't need, and there is USQ Aquila 2, we don't need this 2 columns. What we're gonna write is, the second one is, we write like escape rows equals number of rows that we want to escape. So we're gonna write, since this is 2, we don't need to see the 2, then you hit write 2 and run your code. Okay, hit the run. And if you want to just see what exactly happened, and if you want to check again to what changes they have brought to your data, you can again df.h dot in the parentheses, and then you hit run. So now you can see your data has been nicely and one by one has been given here. Okay. Now you can check your date has been given, time, and also maximum wind speed, average wind speed. So up to the end, which is average, like SID wind speed. And here is only given 5 columns for you. So now it shows very nicely, but still, if you look at the name, here is in front of the date name, there is a semicolon. Okay, so and the others, there are some of them are uppercase, some of them are lowercase. So we want to rename them maybe if we like to. So rename them just nicely. First of all, you want to remove the the comma, semicolon, for example, from here. What you're gonna do is create another code function here, and you write as so df dot columns df dot columns dot strip dot okay, still and like write as a okay, so we want to write as df dot columns equals df data or data frame the columns, okay, columns and string, so that replace inside the brackets the parentheses, sorry, so we add our columns and additional like we give it to 1 comma and double quotation again. So that's it. And then you add a string dot straight. So that's you have a parenthesis. So then you hit the run. If the code is successfully has been affected or applied, there will be a tick mark, which is it means we are happy with this code. So the next thing, as I said here, you can see some of them are in uppercase while others are in lowercase. So we want, for instance, some of the Excel sheet, the data titles should be shortened and written as nice as possible. So here we do not go for all of them. We just want to go for brain data, suppose. So we create a data frame like clean, rain clean, then you hit a bracket. Inside that you're gonna, so okay. So then you're gonna, okay, sorry, my bad. Yep. We have to create a data frame equals to data frame rename, and then you have your columns equals, then you hit the brackets. Inside the brackets, you put whatever you want to change. For instance, we want to change the date name to be like as a lowercase as a date, and what else we want to change, like maximum brain gauge. So here we have, for instance, okay, here, okay, where is it? The maximum, yeah. There is a rain data, rainfall data. Okay, average. So it has been hidden here. What you're gonna do is to display our data. You just need to, at the end of this column, for example, you can write as a df.h, hit, sorry, hit, then hit the run. You will nicely see your data here. So, still we are not able to see our vein data. Anyway, what you're gonna do is the next option is to open your Excel CSV file and see what names has been given for your brain data. For example, we go, yeah, here is total rain, maximum rain. So you copy that name exactly with the same spelling and punctuation, because Python is case sensitive. Otherwise, we may encounter like error message. So how you're gonna just rename it, like, for example, we want to rename it rain max underscore in millimeter. And the next one is we want to go to the for total data, total rainfall also, which is here. Okay, it has been, you can copy and paste your name here. And what you're gonna, how you're gonna just rename this total rain underscore like total underscore millimeter. So that's it. Means we want to rename our date to lowercase as a date, maximum rain gauge as a rain max underscore millimeter, and then total rain gauge as a rain total. Then hit the run. So you will have, as we have a tick mark, it means we are good to go. Then we want to, the next thing, we don't want to take all the data with ourselves or play with all the data. So we want to like extract only the rainfall data. We do not need others' data. So for this, how can you do that? Is by creating a data frame. So clean equals data frame, you add a double brackets inside double quotation. You want to include your date, extract your date along with what else, like rain, maximum rain underscore. Okay, so it is it should be like inside double brackets. So unless, yep. Oh, okay. There is the bracket that I have in double bracket. Inside double bracket, we have rain, maximum rain underscore millimeter. However, you should exactly enter the name that you have renamed to the columns. For example, maximum rain gauge, you have renamed it to rain max underscore millimeter. So again, for the total rain, also we have rain underscore total underscore millimeter. So once you're done with this, you can just add a copy, and then hit the run button. Fortunately, we did not encounter any error message. It means we are good to go. The next one is we want to convert our date. For example, here it has been given as a day, like as a day, month, and year. So until now, the Python is treating our date data as a text. So we want to tell the Python that this is quantitative data. This is a date. So what we're gonna do is just clean the data frame that we have created. So inside the double quotation, you want to include your date. You want to change your date, convert your date to date time. So equals pandas date time. Change it or convert it to date time. And then we create our, so set it as an index also, date. So what then what format we want to change it or convert it. It's gonna be like inside double quotation, you add a percentage mark along with day. Should be in day. D stands for day. And again for month, M stands for month. And then for year, Y stands for year. So once you have done that, here you also have errors. have to add errors and that inside double quotation view course. So once you're done with it, you can hit the run button. As you can see, we did not encounter any issues with that. So it means we are good to go. Next thing is we want to plot our data or visualize our data. As I mentioned at the beginning, for any function that we want to run in Python, we have to install the library for that. Otherwise, we may not be able to do so. For the plotting, we need to import matplotlib, which is for creating plots, and pyplot as plt. Okay, matplotlib pyplot as plt, and then we want to import matplotlib as dates as in dates. Okay. Once you are done with it, hit the run button. So sorry, there should be some spelling mistake or something. Matplotlib. Okay. Matplotlib. Yep, this is correct. Pyplot. Okay, there is a extra L. So pyplot. Then hit your run. So now we should be good to go. And once we have installed our library for creating plots, then we can start our plotting, our visualization by creating PLT, like a data frame for ourselves, figure, or determining the size of our figure, take size, which stands for figure size, equals, for example, inside the parentheses, you add, for example, 14 by 7. So we determine, set this as a like size for our visualization. Then PLT, which stands for plot. So we start our brackets, parentheses, sorry. Then you add your like data frame that you have previously created. What are you going to include? Here we're going to include date. So the same you have to create for total rainfall, maximum rainfall, so on and so forth. So next, rain, maximum rain underscore millimeter. And then you want to label your data. Suppose write as a label equals, so for example, this is our maximum rainfall in millimeter. So once you label it, maybe you give a color also for that. So we hit like blue, for instance. Can give whatever color you like, but I like the blue one. Width, I will go with the blue one. So we set our line width as a 2, for instance. Again, so this is we have created for our date versus maximum rainfall. Now we have to create the same code for our total rainfall also. PLT dot plot, okay, dot start what we want to rain. Data frame that we have created was rain clean. So we want to include date and then rain clean. So at our like total rainfall. This was rain total underscore millimeter. So then again we want, for example, label this one also. label it as like total rainfall, total rainfall in millimeter constants. Okay. Then we also gave a color for this. Suppose we go for rate for this. And then you also give a weight for your like line graphs that you're gonna create. You're gonna give the same size. So that should create our plots, but we want to, if we want to add like legends, title for our graph, we can also do that. Like we create a plot title, for example, we create a title for our graphs. For instance, we're gonna give us maximum is total daily rainfall. Okay. And for example, since this was used Q Toowoomba, and there's Toowoomba at clock. For example, this was the name of our radio station. We just want to create a chart our graph by that name. So once we determine our X label, for example, what we want to be displayed on our X-axis is we want to include our date on the X-axis and okay, on the Y-axis, sorry, you do not need to add a comma here. So plot, and for Y label, we want to what we want to be displayed is gonna be like DFI, rainfall, for instance. So since this is the rainfall data, total rainfall data, maximum rainfall data, in general, we can say it's rainfall. It's a general title for our y-axis axis. And then we want to include it in grade. It should be displayed inside grade. So we're gonna true, say that's a true, then we plot that legend we also want to be displayed. So once you're done with this, you can say, as we just mentioned, first of all, we have determined our figure size 14 by 7, and they created our what we want to include date with maximum rainfall. So the color that we want to go for this line graph will be blue for our maximum rainfall. The line width will be 2. That's again the same goes with the total rainfall. So we have it should be against the date. So we have labeled it as the total rainfall, and the color for the total rainfall will be red. So again, the width of our line will be 2. So in case of our title for our graph, we have chosen as a maximum is total daily rainfall. This is our bigger station name. You can put whatever name you like. So again, we have our date on X-axis, and on Y-axis we have our rainfall. So it should be inside grades, and it should also display a legend. Once we have completed with it, once we are done with it, we hit our run button, and hopefully it will create a nice graph for us. So as we say, there is the title, here is the maximum rainfall and total rainfall. So this is based on our date. It's sorted from 1st of April until today, which was 21st of July. So yeah, that's it for this tutorial. And how you're gonna, for example, download this data, you just right click on that and save as image. Just hit the save button, and it will download for you the nice graph that we have created. Let's have a look here. You can see we have our titles, and on the x-axis we have our rainfall. So yep, and we have our date on x-axis. On our y-axis we have our rainfall data. So that's it. And if you want add like some on the like make it more stylish, you can also do that, whatever you like. So yeah, that's it for today. Thank you. Let me stop recording.